gravity. Not only is it responsible for you not being able to dunk, but it's also responsible for us having air to breathe, our planet being in orbit, us humans not floating into space, and keeping time in check relative to planet Earth. Now, after hearing all of that, you're probably thinking to yourself, that's cool and all, but like, what is gravity? I'm gonna explain that too, so don't worry. Gravity is a fundamental force of nature that governs the attraction between objects with mass. It's the force that pulls objects with mass towards each other, and this applies to everything, even you. You have a force of gravity that attracts other objects with mass. But because your mass is much less than that of, well, the Earth, the force is super close to zero. This gravitational force becomes stronger as the mass of the objects increases, and weaker as the distance between them increases. So that's why even though there are stars millions of times bigger than the Earth, they don't have any noticeable gravitational force on you, because they're insanely far away. The main formula for calculating gravitational force is defined as F equals G times M1 times M2 divided by R, where F is the gravitational force acting upon the two objects, M1 and M2 are their respective masses, and R is the distance between the two objects. I'm gonna go into nerd mode for a second and just clear something up. Mass is not the same thing as weight. Mass is defined as the quantity of matter within an object. Weight, on the other hand, is a force, which is your mass times the strength of gravity quantified in newtons, not pounds or kilograms or whatever unit you want to use. Now that I cleared that up, I'm going to show you another formula, which is for gravitational fields. A gravitational field is a region of space surrounding a mass where another mass experiences a force due to gravity. In simpler terms, it's the area around an object where the influence of its gravitational pull can be felt by other objects with mass. You can calculate this with the formula lowercase g equals uppercase G times m divided by r squared, where the little g is the gravitational field strength, g is the gravitational constant, m is the mass of the object generating the field, and r is the distance from it. If we do some quick Google searches, we can figure out the gravitational field strength of Earth. So roughly, if the Earth has 5.972 times 10 to the 24th power kilograms of mass, and has a radius of 6,378,000 meters, we can plug that into the formula and get the value of 9.79. Pretty close to the value of gravity that you might know, which is 9.81. The gravitational field strength is typically measured in units of acceleration, such as meters per second squared or in newtons per kilogram. Both of these units essentially express the same concept: how much acceleration an object experiences due to gravity per unit mass. So for Earth, you would experience a gravitational force of 9.8 newtons per kilogram, giving you your weight or the force that acts on you at all times by Earth. While that's cool and all, what isn't clear is exactly how mass causes gravity, and that stuff is way above my pay grade. So that's where we bring in the GOAT, Albert Einstein. According to Bro's law of relativity, gravity is described as the curvature of space-time caused by the presence of mass and energy. According to this theory, massive objects like planets and stars create a gravity well in the fabric of space-time, causing other objects to move along curved paths in response to this curvature. In Einstein's general theory of relativity, gravity is conceptualized as the curvature of space-time, a four-dimensional framework that combines space and time into a single entity. This space has three dimensions, like the world we know and live in, and time is the fourth dimension. Imagine space-time as a flexible, stretchable fabric, like a trampoline, where massive objects create depressions or gravity wells in this fabric. For example, imagine a bowling ball in the center of a trampoline. The weight of the ball causes the trampoline surface to curve downward around it. Similarly, massive objects like planets and stars create distortions in the fabric of space-time, causing it to curve around them. When another object, such as a smaller ball, rolls across the trampoline surface, it doesn't move in a straight line, but rather follows a curved path towards the bowling ball's depression. In the same way, objects with mass move along curved paths in response to the curvature of spacetime created by the mass, and this attraction would be the force of gravity. So those are the basics of gravity. And obviously there's a lot more to cover with relativity and the possibility of the graviton particle, but that stuff is way too hard to explain in a 5-minute YouTube video. So if you want to learn stuff like that, maybe I'll make a video about it in the future. But if you want to learn complex physics from someone that isn't stupid, like me, I would recommend going to college and learning it from someone a bit more intelligent. In reality though, I'm just a guy who likes science. So make sure to subscribe if you thought this video was sick as